Hello, today we will discuss some problems on kinematic equations. So I am writing one problem here. Moving with uniform acceleration, a body moving with uniform acceleration, a body covers 150 meter during 10 seconds. During 10 seconds. So that it covers 24 meter during in 10th second. Find the initial velocity and acceleration of the body is. So this is the question. So what is the question here? Moving with uniform acceleration, a body covers 150 meter during 10 seconds, so that it covers 24 meter during in 10th second. Find the initial velocity and acceleration of the body is. This is the question. So have you copied the question first? Yes or no? Have you copied it? See here, look here, moving with uniform acceleration. Moving with uniform acceleration. That is, so the body has uniform acceleration. The body has uniform acceleration. A body covers 150 meter in 10 seconds. So the body, for example, this is the body. It is moving with uniform acceleration. It covers 150 meter in 10 seconds. So here we have one more information. 24 meter in the 10th second of its journey. 10th second of its journey. That means 10th second displacement covered in 10th second of its journey is equal to 24 meter. 24 meter. We have the formula. See here we have the formula Sn equal to u plus a n minus of. U plus a n minus of. This is nth second displacement. This is the kinematic equations of linear motions is the fourth formula for you. I already explained in the last class 4 equations how to we use the equations. When the body is in uniform acceleration only we can use these 4 equations. So this is the fourth equation. Here Sn is nothing but the displacement covered by the body in nth second, which is moving with initial velocity u. It is moving with uniform acceleration. Here n is nth second. If it is first second, substitute n equal to 1. And if it is second, substitute n equal to 2. If it is seventh second, substitute equal to seventh second. So here we have the 10th second, so that is equal to n equal to 10. So I am substituting now Sn. I substituted here, instead of n I substituted 10, that is equal to u we don't know, u plus a acceleration, n equal to 10 minus half. So this is equation 1. So here S10 is nothing but 24 meters. Is it okay? 24 meter equal to u plus a of, otherwise you just like that, 10a minus a by 2. This is the equation number 1. Equation number 1. Then also we will 10a 20a minus a 19a by 2, 24 equal to, this also we can use equation number 1. So up to, you just write the equation up to here. After copying this I will explain little bit more. See, simply what I did here, the body is moving with uniform acceleration. It covers 150 meter during 10 seconds, so that it covers 24 meter during it in its 10th second. 10th second only, particular 10 second only, he covered 24 meter. The body covered 24 meter in 10th second only. That means in particular 10th second it covered 24 meters. For that one, S10 equal to 24 meters. So here the formula we have the Sn equal to u plus a of n minus half. Here Sn equal to 24, u plus a 10 minus half, 10a minus a by 2, 19a by 2. You have the equation. So now next, now we have the form. We got one equation here. What is that? This one only. So here I am doing one more. The body covers 150 meter, which is moving with acceleration a, time it 10 seconds. In 10 seconds it covered 150 meter. So for this information, S equal to ut plus of at square. S equal to ut plus of at square. Here S equal to displacement, u is initial velocity, t is time, of a is acceleration, uniform acceleration, t is time. So substitute these values here. 150 equal to, we don't know how much initial velocity for this. So t equal to 10 seconds. It traveled, the body traveled for 10 seconds. It covered 150 meters. So u into 10 plus of into a, we don't know, t square, 10 into 10 square. So for this one, 150 equal to 10u plus, see, 10 square is nothing but 100, 2 1 ja 250 ja, you will get 50a. See here we got what we got the equation here, 150 equal to 10u plus 50a. Here also we have one more equation. This is second equation, this is the first equation. So we can change the equation like this. Is it visible first? So okay, I'm changing here. 24 equal to u plus 19a by 2. Is it u plus a 10th minus 1 by 2 u plus 10a minus a by 2. So u plus 19 a by 2 it is there, that is equal to 24. So this equation we have just before, so I am converting. This is 48 equal to 2u plus 19a. This is the first equation. So from these two equations, solve for initial velocity and acceleration. You will get the answer. So we have two equations here. What are two equations here? First one is 48 equal to 2u plus 19a. Second equation 150 equal to 10u plus 50a. From these two equations we can solve for u1 a value. So here just I am substituting here, take minus minus minus, so multiply with this 5, then you will get 48 into 5, 48 into 5, 5 8 is 40, 5 by 240, 240 equal to 10 into 5, 10u plus 95a. Here it is 150 equal to 10u plus 50a. So already it is plus is there, remove plus, put minus minus minus. So this will cancel. You will get here 45a plus, that is equal to 240 minus 150, 90. You will get 90 by 45, you will get 2 meter per second square. 2 meter per second square. So you just copy it. We got the acceleration of the body. That is 2 meter per second square. So if we copied, I will go for calculation of initial velocity, that is u. Did you copy? Up to here we got a equal to 2 meter per second. Then message me yes. Yes, okay. Then see, we have, this is the first equation. So here we have the two variables u1 a. Already we got a equal to 2 meter per second square. So just substitute here, then find u. So that is equal to 48 equal to 2u plus 19 into a equal to, we got 2 meter per second square, 19 into 2. 2u plus 19 into 2, 38. This will become 48. So here we have to find u value. 2u plus 38 equal to 48. Then 2u equal to 48 minus 38, that is equal to 10. 2u equal to 10. 2u equal to, we got 2u equal to 10, then u equal to 10 by 2, then we will get 5 meter per second. So we calculated a value, that is equal to 2 meter per second square, u equal to 5 meter per second. So like this we are applying kinematic equations to this question. So the question is, moving with uniform acceleration, a body covers 150 meter during 10 seconds, so that it covers 24 meter during in its 10th second. find the initial velocity and acceleration of the body is, we got two values here, u equal to 5 meter per second, a equal to 2 meter per second square. Have you understand? Just message me yes. Next, so like this we're not understanding. See what happens here, solving the equation is a mathematical part. If you know solving equations, so geometrical, see solving equation you will get in 9th class I think in maths. Then you can solve for variables u and a values like that. Is there problem? I think you have the problem there only. Okay, in solving the problem or understanding the problem, which, where is your doubt? Solving or understanding? Just message me. The first equation I have, in the first equation, what is the first equation? What happens here? Just you can call to my number, no problem, directly you can call, you can call me here. You just call me. See here, see what happens here, 24 u plus 19a by 2. Actually this is the question, this is the equation. So I am changing, see what I have changed here, 24 by 1, 24 by 1 u by 1, 24 by 1 equal to u by 1 plus 19a by 2. Just multiply this equation with 2. So 2 into 24, 48, 2 into u, 2u plus 2 into 19a by 2, then will 2 will get cancelled, 19a will get. Is it okay now? Just I multiplied this equation with 2. I multiplied this equation with 2, then this equation changed to this one. This is the first equation. How did I change? Did you understand now? Have you understand now? Okay, right, that's it. So like this, if you have some mathematically, if you are strong in basics, you can do these things simply. So I want to change topic now. Today I am discussing somewhat new topic, motion under gravity. Motion under gravity. Motion under gravity means, see this is the earth, this is the earth. If you drop anything, it will come and touch the ground, it will fall on the ground. Why it is falling? Why it is moving? If you drop any body, any particle, any body, it is coming down only. Why it is not moving up? This is the topic. See, the earth attract the bodies. Earth attract the bodies. So how it is attracting? For example, this is a particle, this is the body. It is coming down. This is coming down due to earth attraction. So that we can call as gravitational force. Gravitational force. See, due to gravitational force, this body comes down and fall on the ground. Comes down and fall on the ground. So the earth is attracting, the gravitational force will come from earth only. Gravitational force will come from earth. Earth will attract the body. Attract the body. So here this is the body, this is the earth. The body is attracting by the earth, so that's why the body is falling, lastly fallen on the ground. So every object or any particle, it will comes down to the earth. So here the body is accelerating. So the body is accelerating. For example, it has initial velocity 0. See, simply we drop the ball on the earth. So I will explain. This is the earth. This is the ball. What happens here? The ball will come down. It will attracted by earth. So if it has some velocity, for example, it does not have any velocity initially, u equal to 0, then we drop the ball will come down, comes to the earth and fall on the earth. So during this, the earth will attract this ball with some gravitational force. So by this force, the ball will accelerate. The ball will accelerate and comes to the earth. So the acceleration value of gravitational force due to gravity, the ball will get acceleration equal to 9.8 meter per second square. So this acceleration is acting by the gravitational force. That's why we are denoting with G. So here you just write gravitational acceleration. Gravitational acceleration G equal to 9.8 meter per second square. 9.8 meter per second square. See, G value is 9.8 meter per second square. Gravitational acceleration. Just you write this formula, this value G equal to 9.8 meter per second square. For example, what it means, if you drop any body or any particle, it will come to the earth. Due to this earth gravitational force, the body will accelerate. It will get acceleration that is equal to 9.8 meter per second. So for example, here of the body, it will go with 9.8 meter per second square. If it is there, 9.8 meter per second square. So the body will attract the earth will attract the object. The object will get acceleration. That acceleration is nothing but gravitational acceleration, that is equal to 9.8 meter per second square. 9.8 meter per second square. You just try this one. So this value G equal to 9.8 meter per second square. This is in MKS system. In CGS system, 9.8 centimeter per second square in CGS system. So this value just you copied and underline it. Okay. Next, Next, see what you understand from these things. What I said to you, the earth will attract any body. If there is a smaller body or larger body, 1 kg body or 2 kg body, 100 kg body, every body, any body will attract by earth. The earth attract means it is acting force on that body. The earth acting force on this body. The body, when force acted by the earth, the body will get accelerated. The body will get accelerated. That acceleration is equal to, that is gravitational acceleration, equal to 9.8 meter per second square. In MK system, if we go for CJ system, 980 centimeter per second square. So this is the information, motion under gravity. Simple. Okay. Then one more point you have to remember. G value. So G value, G is, what is G here? Gravitational acceleration. So G value will be different at different places. That means this is the earth. So this is the equatorial line. Equatorial line. Here the pole. Here also pole. So the G value is different here and G value different here. So place to place, that means on equatorial line at this place the G value is somewhat different compared to at the pole. So G value changing on the earth according to different places. If you go for pole, G value is different from, if you go for equatorial line, the G value different from pole. So this is a small information I am giving to you. Next, I will go to one more topic. Freely falling body. Freely falling body. Freely falling body. Freely falling body means, see here the earth, the body is here. We are leaving the body with initial velocity 0. Just we are not giving any velocity to that body while we are leaving that. Just we are leaving that body. It will come down. So the initial velocity for this body is equal to 0. Then it will comes down. Then it will comes down. So what happens here? See the freely falling body here under gravity. Under gravity. Gravitational field is there. The earth is attracting that body. Say U equal to 0. It covers to touch the ground H displacement. H displacement. So if it covered H displacement, the body is moving with initial velocity 0. For time t it travel. If the body travel for time t. So then what about kinematic equations about this case? This is important case. See what I discuss here. Freely falling body. Freely falling body. Simply I leave the body without any initial velocity. It has no velocity. Simply I got the ball. Just I leave the ball. Simply I open the fingers. Then the ball will goes down. So what happens at that time? U equal to 0. It will comes down and reach the earth. So I am considering the distance covered by that body is h in time t. So what about acceleration? It will get acceleration. acceleration, that is equal to A equal to plus G. A equal to plus G. So for this we apply kinematic equations. For this case we apply kinematic equations. For first kinematic equation, equation of linear motion, V equal to U plus AT. Second equation, S equal to UT plus half AT square. Third equation, V square minus U square equal to 2AS. Fourth equation, Sn equal to U plus A of n minus of. These are the kinematic equations we have already learnt. So I am applying this first equation to this case. What is this case? U equal to 0 freely falling body conditions. You just write these conditions. U equal 0, A equal to plus C. These two conditions are there. U equal to 0, A equal to plus G. So these conditions applied for freely falling body. Freely falling, that is equal to U equal to 0. A equal to plus Z plus G. So by using these two conditions, we can find final velocity, displacement covered by the body, then in nth second how it travel the body. Like that we can apply these four equations. So now I am checking. See here, what are the conditions of freely falling body? U equal 0, A equal to plus C. Now first kinematic equation, V equal to U plus AT. See here the body is there, it is moving with U equal to 0. U equal to 0 means initial velocity is 0, then touching the ground. What is the final velocity of the body? For final velocity, if we want to calculate final velocity of the body, we can apply this equation. So here V equal to U, already for freely falling body the condition is U equal to 0, A equal to plus G into T. 0 plus into plus GT, V equal to GT. So if we drop a ball from some height, if you open our fingers, the body will come down to the earth. When we are dropping, the initial velocity of the ball is 0. It traveled for example t time. What is the final velocity when it reached the ground? So for that one, V equal to GT. Simply we applied this first kinematic equation to this case. What are the conditions of freely falling body? U equal 0, A equal plus C. U equal 0, A equal plus C. V equal to GT. Second, see the body started with initial velocity 0. It traveled for t time. It traveled a distance of h. So my question is, how much distance covered by the body before reaching the ground? So we have the kinematic equation 2, S equal to ut plus half at square. Here h equal to the covered by the body which is falling with the initial velocity 0. So I am substituting h equal to, here u is 0, u 0 into t 0 plus half a equal to what? A equal to, already we have the condition, plus c g t square. So h equal to half gt square. This is also very important formulas. See, look here, h equal to, we got half gt square, h equal to half gt square. See what we are doing here. I taken one case here, freely falling body. For freely falling body, what are the conditions? For freely falling body, initial velocity is 0, acceleration equal to plus g. What is g here? Gravitational acceleration. Already I explained. If you are not understanding, if you did not listen my before this topic, I will send this video after completion of live. Just you revisit this video. So here a equal to plus z. For freely falling body, u equal 0, a equal plus z. I just substituted here u equal 0, a equal plus z. The distance covered by the body which is moving with starting with initial velocity 0, h equal to half gt square. H equal to half gt square. Next, you just copy it. Have you copied? Have you copied? Okay. So here we will check by using kinematic equations. I will check. So conditions, I'm writing on top of this freely falling body. Freely falling body. Freely falling body. Conditions are u equal to 0, a equal to plus c. These are two conditions for this case. So here, this is the wall, this is the surface of the earth, the ball is coming down. So in first second displacement, it started with u equal 0, then a equal to plus g. In first second displacement of this body, I want to calculate first second displacement. So this is important case. First second displacement. First second displacement. So we have the formula Sn equal to u plus a n minus of. Here the conditions already we know, u equal to 0, a equal to plus g. First second means n equal to 1. Here S1, u equal to 0 plus a equal to plus g, n equal to 1, 1 minus of, that is equal to g of, that is nothing but g by 2. So S1 in first second displacement is equal to g by 2. Have you understand this one? Have you understand up to this freely falling body? Have you understand what are the conditions for freely falling body? U equal 0, a equal to plus g. See, I am calculating now first second displacement. In first second after dropping, how much displacement covered in first second only. See, for example, I dropped the ball at 10 equal to t equal to 5:30. Then here 5:31 seconds. 30 seconds it started, 31 seconds. In first second, how much displacement covered by the body? For that one, u equal to 0, a equal to plus g. Have you understand? Just I taken this nth second displacement formula. I substituted n equal to 1, that is s1 equal to u equal to 0, g of n minus n equal to 1, 1 minus 1 by 2, that is equal to 1 by 2, g by 2, s1 equal to plus g by 2. So here what we are understanding here, in 1 second, in first second, the displacement. So I will go for next in second displacement. Just you do this one, substitute n equal to 2, u equal to 0, a equal to plus. Substitute in this formula and do it. Come on, do it and say. Have you done? Did you get? See, for second displacement. So up to here the body taken 1 second, up to here second. So how much displacement covered in this second only? In particular this second only. Already we calculated up to this here to here. In 1 second this one, second. So that is equal to, see, we will see S2. So already we have the formula Sn u plus a of n minus half, that is equal to, conditions are u equal to 0 for freely falling body, u equal to 0 plus a equal to g, second 2 minus of g of 2 to the 4, 4 minus 3 by 2. So S2 will get 3g by 2. 3g by 2. Good. You did well. Next, I'm asking third second displacement. Just you calculate. Third second displacement. What are the conditions? Third second means up to here. In third second, covered by the body, this is third second, n equal to 3, u equal to 0, a equal to plus. Just calculate and tell me the answer. For this one, u plus a n minus half, ls3, no, you just substitute third second, u equal to 0, 0 plus a equal to g, 2 3 is 6, 6 minus 1, 5 by 2, s3 equal to 5g by 2, s3 equal to 5g by 2. Is it? So now I am comparing first second displacement east, second displacement east, third second displacement equal to first second displacement, what? G by 2 east, 3g by 2 is to 5g by 2. So we can cancel g 2 in the ratio. So 1 is to 3 is to 5. First, second displacement, second displacement, third, second displacement. This is the ratio. 1 is to 3 is to 5. 1 is to 3 is to 5. So like this, we are applying kinematic equations to freely falling body. Freely falling body. For freely falling body, you have to use these two conditions: u equal to 0, initial velocity equal to 0, a equal to plus g. Okay, nice. Just copy it. Okay. Now next, what are the conditions for freely falling body? U equal to 0, a equal to plus z. So just I will check one more. The ball or a body falling with u equal to 0 onto the ground. So here it travel h displacement in time t. What is the final velocity? So acceleration already we know, plus z. So we can apply for this one final velocity of the body when it touches ground. Body when it touches the ground. The body when it touches the ground, what is the final velocity? Before touching the ground, after touching the ground, the final velocity will be 0 because there is no velocity. So before touching the, when it touches the, before touch. So here v square minus u square equal to 2as. We have the third kinematic equation here. So here v square equal to minus u square goes to this side, right side, plus u square plus 2as. So for freely falling body, we have only two conditions: u equal to 0, a equal to plus 0 square plus 2g. Here the body covered displacement, that is s equal to h. Just instead of s I am using here h. So h v square. So v equal to 2gh under root. V square equal to under root of 2gh. This is final velocity of the body when it before touching the ground. Ground touches mundu. What is the velocity? It started with u equal to 0. Of when it touches, the velocity will be 2gh. So it started with u equal to 0. Finally, when it touches the ground, the velocity goes to increase 2gh under root of 2gh. So how much time taken also we can find. How much time taken also we have to find it here. So here the time taken by the body. time taken by the body before touch the ground. So we have the formula S equal to ut plus of at square. So here S equal to h, u equal to 0, so this term goes to 0, 0 plus of gt square, half gt square, h equal to half gt square, t equal to 2h by g under root. So we have two formulas here in freely falling body. For freely falling body, we have two conditions: u equal 0, a equal to plus z. So the body starts with initial velocity 0 before touching the ground, that is earth. The final velocity of that body is equal to 2gh. H is the body covered before touching the ground. The body covered displacement before touching the ground, that is equal to the root of 2gh. So then I want to calculate time, the time taken by the body before touching the ground. See, it started here and touched the ground. How much time taken? So I used this as second equation here. S equal to ut plus half at square. Here u equal to 0 plus half gt square. Just for t equal to 2h by g. T equal to under root of 2h by g. So these are the main conditions in freely falling body. In freely falling body. So you just copy it. Just copy it. I will give one problem to you. Then do it. After copying, message me completed. Then I will give one problem to you. Okay, completed? Yes. Okay. Now I will give one problem to you based on v equal to 2gh. Then you can understand. A freely falling body, a freely falling body covered 9 meter before touching the ground so what is its final velocity of the body? So this is the question. Just you copy the question first. So here what happens? The freely falling body means you have to take two conditions: u equal 0, a equal to plus z. The body will come down to the earth. It traveled. Here I taken 9.8 meter. Just you take it 9.8 meter from here to here distance before touching it. So my question is, what is the final velocity? What is the final velocity? So already I given the problem: v equal to 2gh under root 2 into g value is equal to 9.8 meter per second square. Already I told you, motion under gravity 9.8. H is nothing but the displacement. Here it is 9.8. h equal to 9.8 meters, g equal to 9.8 meter per second square. I substituted here. Here we have 2 9.8 under root, so take 1 9.2 meter per second. Is it? It is simple. Say for freely falling body, u equal 0, a equal plus z. So g value 9.8 meter per second, h equal 9.8 meter. So for based on this one, I will give some homework for you. You simply first you copy this one. G equal to 9.8 meter per second square, h equal to 9.8 meter. Final velocity how much? Just calculate like this. Then g equal to 9.8 meter per second square, h equal to 19.6 meter, v equal to what? G equal to 9.8 meter per second square, h equal to 39.4 meter, v equal to what? So these are 3 questions. Do for homework. Okay. Simply g value is fixed 9.8 meter per second, that is gravitational acceleration 9.8. h is height. So from this height the ball fallen, and after finally it fallen on the earth. Okay, you just copy the homework also. Not visible this one. Okay. Writing here g equal to 9.8, h equal to 9.8 meter. What is the b? G equal to 9.8, h equal to 19.6 meter. What is v? G equal to 9.8 meter per second square, h equal to 39.4 meter. What is v equal? You just copy these things. Is it visible now? Come on, do. Just copy it and do the problems. Homework for you. Okay, bye bye. Okay. Have you copied?